Welcome. I am Andrew Hare, Supervisory East Asian Painting Conservator in the Department of Conservation and Scientific Research at the Freer Gallery of Art and Arthur M. Sackler Gallery, the Smithsonian's National Museum of Asian Art. I am delighted to welcome you today to our lunchtime series, Sneak Peek, New Research from the Freer and Sackler. Today's program, Beyond the Naked Eye, Inks of Asia, presented by Jennifer Giaccai, conservation scientist, will take a closer look at traditional East Asian carbon-based inks and her research using Raman spectroscopy to identify ink sources without taking samples from artworks. I am delighted to introduce our speaker today. Jennifer Giaccai is a conservation scientist in the Department of Conservation and Scientific Research at the Freer Gallery of Art and Arthur M. Sackler Gallery, as I said, the Smithsonian's National Museum of Asian Art. She previously worked at the Smithsonian's Museum Conservation Institute and the Walters Art Museum in Baltimore, Maryland. She joined the Freer and Sackler in 2015. Her current research interests include tracing the introduction of modern pigments in Chinese painting and analyzing the dyes in the embroidery of Ming dynasty rank badges, as well as researching the pigments used in Indian picchwai. Jennifer, the floor is yours.
So thank you very much. I'd like to talk to you today about the inks of Asia. I want to thank all of you for coming to listen. And it might sound like I'm starting out a little bit from the basics, but I'm going to talk a little bit about what is ink at first. Now, I'm going to focus in this talk on East Asian inks. So from Korea, Japan, and China. And if you can see, let me put my laser pointer on. This ink stick over here is the common form of what's often referred to as Chinese ink, but is really East Asian ink, is used in the form of an ink stick. And I'll talk a little bit more about ink sticks further on in this talk. But ink sticks are made out of soot. That's the black pigment that gives them the ink color. And soot-based inks are also used in most of Southeast Asia and South Asia. So hopefully all the research we're doing on soots now will also be applicable to our collections in those areas. In addition, the Middle East uses soot-based inks, iron gall inks, and mixtures of soot and iron gall inks together. And again, hopefully all of our work that we're doing now on soots and that you'll hear about a little bit about today will be applicable to those areas of our collection in the future. So the next question you might be talking about is why ink? You know, it's sort of, especially if you think of some of the paintings in our collection, they can be like these bright, colorful portraits like you see over here. And one of the issues with that is that pigments are very well studied in the scientific conservation science community. You know, we know all in this portrait, we know what all of the pigments are, we know how to identify them, we know how they were made, if they were man-made, or if they're natural, how to differentiate between, if they, you know, sometimes the same pigment can't actually be man-made or natural, how to tell apart the difference between those. If they're man-made, what the process of making them is. The green pigment in this portrait was a pigment that was invented in 1838. So we were able to narrow down the date range of this painting to the mid to late 19th century based on the use of that pigment in this painting. And so we can get a lot of information from the materials that a work of art is made of. However, inks, and I think most people who are familiar with East Asian artwork will know that there are just many, many works of art that are comprised solely of ink-based paintings or calligraphy. And inks, unfortunately, soots, the colorant in those black inks is not fully understood. There's a huge combustion community that is constantly striving to learn more and more about soot, and that's something that we're hoping to work into our studies here as well. You know, on this painting in particular, I chose it because we happen to know that the painting and this inscription are a few hundred years apart. The inscription was added much later in the painting's lifetime. And so we know that these are different inks, when it's added a few centuries after the painting is painted, but we don't necessarily know that about all of the works in our collection. And in addition, we may not, we don't know if the artist used a different type of ink for certain parts of the painting or not. So those are all things to sort of like to explore and learn more about in studying inks. Now, the requirements for the study are that we'd like it to be non-destructive or non-sampling. It's maybe hard to see on your computer screen, but these are very thin washes of ink. Taking a sample from that is prohibitive, and indeed, our department as a whole is constantly striving to more and more non-destructive and non-sampling methods of analysis. And we'd like to focus on the soot, not the adhesive that's being used. And hopefully that will become clear later on in the presentation why that's so. So just to give you a little bit of background information about ink sticks, this is an ink stick in our collection. You can see that in addition to the plain one that you saw earlier in this presentation, here we have this very decorative ink stick. Ink sticks are collectibles in their own right. All of the images, most of the images of ink sticks you'll see today are those from our collection. And an ink stick is used because it's nice, it's portable, it's easy to carry around. Anyone who's had a pen explode in their pocket or their purse will understand the advantage of having a dry ink form. And by using an inkstone, and here this is a very plain inkstone, and a few drops of water, you can rub the ink stick on it and make your ink immediately for use just that day, just at that moment in time. In addition, ink sticks are often gifts. We have ink sticks in the Freer Gallery of Art collection that were given to Charles Lang Freer by people who, as a method of honoring him by giving him these gifts of ink sticks. What we also know is ink is something that's written about extensively by painters and calligraphers, and they talk about the ink qualities themselves varying depending on the soot type that was used. So although I will talk more about the different soots that are used in the inks after we talk a little bit more about how ink sticks themselves are made. So ink sticks are made by a mixture of animal glue and soot. So animal glue you can think of as very similar to gelatin. If you think about Jell-O at room temperature or in the refrigerator, it's solid, but you heat it up and it becomes liquid. And the same thing is going on when you're making an ink, East Asian ink. You're heating the animal glue up until it becomes liquid and then mixing it with soot, and then it's kneaded together extensively. And it's actually still kept warm while it's being kneaded. So here's a traditional method of kneading. You can see the ink here on top of the anvil that this workman is hammering. And that's the anvils themselves are heated to keep the ink mixture malleable and allow it to mix more thoroughly. And I was told when we were traveling in China that traditionally you would beat with a hammer your ink mass 10,000 times. So this is not just sort of, okay, you're kneading your bread dough together 5 minutes and you're done. This is a really extensive mixing process. Nowadays, it can sometimes be done on machine. And I apologize that some of these photos are really dark. You can imagine in workshops where everything is made with soot that gets everywhere and is very black. There's just not always as much contrast as we might want in the photos. But you might be able to see the steam rising from the ink mass as it's being kneaded in what looks like a gigantic pasta machine. So while that ink mixture is still warm, it is rolled into a cylinder and then pressed into a wooden ink mold and kept under pressure while it cools. And then after it is cooled, the ink stick is trimmed. And the molds themselves are another sort of art form for the craftsmen in East Asia. These molds are traditionally carved from pear wood, and a mold can be used about 1,000 times before the wood impression starts to dull enough that it's considered not good to use anymore, and they will recarve the mold or change out the mold for a new design. And ink sticks are then dried for 6 months to 2 years. So you can see this is a very labor-intensive and long process. These are very revered possessions. In Japan, they would dry the ink sticks in ash to slowly draw the moisture out of that animal glue and soot mixture, and then hang them to dry. And you can see they're all individually hung in these strands so that you don't get any mold or mildew built up as the ink sticks are slowly curing. Whereas in China, the ink sticks are dried in air. It's off to the side here. This is a rack, and this room is very long and deep, and it is just filled to the brim with rack after rack after rack of ink sticks. Here you can see a couple workers. Every day they go in and pull out the racks and flip those ink sticks over every single day, again, to make sure that you don't have any chance for mildew or mold to build up on the surface of the ink stick while it's drying. Cylinders, because they're round, you don't want them to be resting on their side and possibly getting out of shape. And so they're hung to dry. And again, you can just see how many of them are in place there in the factory eaves. And another thing that we noticed in China is that some ink sticks are actually pressed and dried. And this is in order to increase the density of the ink stick to give a nice quality, heavy feeling ink stick. And so no matter what type of soot is used in making the ink stick manufacturing process is always the same. However, the soot manufacturing itself is quite different, as you'll see. So even though the ink sticks are treated the same and the end product has only small differences to the naked eye, if that, the soots themselves can be quite different. So lampblack is the first traditional soot I'm going to talk about. If this inspires you and you go off and do a whole bunch of research, you may be confused. Sometimes lampblack is used synonymously with carbon black, but in this talk, I'm going to refer specifically to making lampblack by burning either vegetable oils or animal fats. That those are the fuel sources that are used for making lampblack. Lampblack is thought to have a brownish tinge or lend a shiny quality to the inks that are made from it. And lampblack is made by, you have a bowl here of, in this case, canola or rapeseed oil with a wick in the center. And this arc sort of that's hidden in the shadows up above is a second bowl that's on top of the flame. And it's about 10 centimeters away from the flame, as I said before, and every 20 minutes, that bowl is rotated. And the workman just sort of goes and rotates all of the bowl covers. And then by the time he's done with the whole room, it's time to start again, rotating. And every couple of hours, he'll go through and remove the bowl and brush out all of the soot into the collection vessel, and then start the process over again, recollecting soot over that wick. In China, they do use the traditional method that we talked about on the previous slide, but they've also started to introduce a more modern method that requires a little bit less constant manpower. And so they've built these long furnaces for making the soot, and they're still putting in a mixture of animal and vegetable oils. In this particular factory, they're using a mixture of tung oil and pig fat, which is one of the traditional mixtures used in making Chinese ink. And you can see, though, instead of having only one wick, they'll have a whole row of wicks. And then they've got a drum constantly rotating over the top of the wicks that's collecting the soot and then rotating back and dropping the soot off into the collection vessel and then rotating back forward to get new soot, and so on. The next soot that is sort of the second of the two traditional soots used for making East Asian inks is pine soot, and it's exactly what it talks about. It's or sounds like. It's soot that's made from pine wood. It's thought to have a bluish tinge to it when it's made into an ink. It can be made from pine branches or pine roots or leftover bits of pine wood. And this here is woodblock print from a Ming dynasty technical manual that was showing how pine soot was made back during the Ming dynasty. where you have a big pine wood fire here at the end and a long chimney with these sort of made from these removable fabric panels. And they'd burn their pine wood, and then after the fire had stopped, all their wood was burnt, they would let the chimney cool down until it was, able to be handled, and then they'd start collecting the soot. And as they collected the soot, the canvas panels that were furthest away were considered to have the highest quality pine soot. And you can compare that to the lampblack, which is collected right over the flame. In modern China and Japan, pine soot is still made in very similar fashions. You don't see those long, flammable chimneys as much now as somewhat more safe methods. But here, for example, at this workshop in Japan, he has a small pine wood fire here, and this chimney is actually quite lengthy. It's a few meters and goes into the center of this very large fiberglass box that's collecting the pine soot. This is actually looking just sort of at the interior of this pine soot collection chamber, and you can see how thickly that pine soot has started to build up on the walls of that chamber. It actually hangs down like stalactites from the air, but as you can imagine, no picture that I took of that came out clearly. Over here, you have a workman who runs his own one-man shop where he makes all of his own soots and is the only person making ink sticks in his shop. And he set up a pine soot manufacturing where he has a little sort of barrel furnace here and the long chimney to let the soot cool down some. And then he has his pine soot collection room here in the back corner of the room. A Sung dynasty method has a similar idea where you have your pine wood fire in the bottom and then a series of chimneys. And again, the highest quality pine soot is considered to come furthest from the flame here in the top chimneys. And I need to mention carbon black. So I was saying before we were discriminating between lamp black and carbon black. Well, carbon black in this context today, I'm referring to the material that was sort of invented in the late 19th and early 20th century when we discovered, mineral oils and hydrocarbon, natural gas, and started using those in our everyday life. And so soots are made in the same way. This is a carbon black factory in West Virginia in the early 1900s. The carbon black factories, even today, are always situated close to the source of the natural gas or the oil that's used to make them. And so this was, the natural gas fields in West Virginia had all of these carbon black factories. And then when they dried up, those carbon black factories moved out to areas with newer, fresher natural gas fields. Carbon black is believed to have a purplish tone, and its main uses today, carbon black is extensively made and in a variety of different methods, but its main uses today are industrial. Our car tires are black because the carbon black strengthens the rubber in car tires and makes them more resistant to wear. Commercial inks, any sort of printed piece of junk mail or anything that's coming from a laser printer that you have surrounding you on your desk is probably printed from carbon black in the printer toner or the commercial ink that was used. But why am I talking to you about them today? The fact is, any modern artist in the late 19th or early 20th century may have used an ink stick that was made with carbon black. Some of the workshops that we visited in China and Japan are using carbon black as a soot source for their ink sticks. And so, although we would never expect to see it on a historic painting, it may be something that is in some of the more modern parts of our collection. And so I am a scientist. Now I'm going to get into the sciencey stuff. Hopefully I've left this at a level. My goal is not to teach you the intricacies of it, but really what we're learning from the scientific analysis of soot. So our goals when we started this project were, can we differentiate between pine soot and lamp black on our works of art? Can we differentiate between two different works of art on the artwork, between the inscription and the painting, or say the distant mountains versus the up close trees, or those using different inks? And then how narrowly can we identify the soot that was used in an ink? Can we actually trace it back to an individual workshop or an individual ink stick? What kind of information can we start to get out of this? And as Andrew mentioned earlier, the tool we're using for this is Raman spectroscopy. Raman spectroscopy identifies the bonds that are in the molecules. And so it's looking at the different parts of the soot that are all held together by those chemical bonds. The wonderful thing about Raman spectroscopy as a museum scientist is that it can be undertaken in situ on works of art. For a few decades now, Raman has been used to investigate different works of art, different colored pigments, ceramics, and so on. And it has a very small spot size. It has about a 50 micrometer spot size. To give you an idea, that's sort of the size of the diameter of a strand of hair. And there is a little sort of dot here in the center of, this is not a work of art, but just some ink painted out on a piece of paper. And that dot is actually larger than the area we're examining. Because Raman is a scattering technique, the laser is shooting down at the work of art and scattering off, and we're measuring that scatter. And those scattering off things are what we see with our naked eye. Because we are using laser excitation, we need to be very careful when we're doing it that we're not causing any damage, both damage to the painting as a whole, but also damage just to the individual soot and the bonds in the soot we need to be careful of. So we do that by keeping a very low laser power and by regularly monitoring the laser power and the spectrum that we're getting from the work of art. We can tell and make sure that we're always operating in a safe range. And I recognize that this whole thing is talking about soot and East Asian inks, but I just wanted to give you a little bit of a picture of Raman spectroscopy of some other carbon-based inks, because they are, or carbon-based pigments, they are all very similar. So we have graphite pencil, the same as you use, your 2B pencil that you'll use for math tests and so on, gives you these very sharp peaks here that you can see in the graphite pencil spectrum. Whereas a stick of charcoal, and again, neither graphite nor charcoal are used very often in East Asian works of art, but they are used in other works of art around the world. And charcoal has this sort of side lump over to the side. So we have the two main peaks here. We have the side lump for charcoal. And India ink, which is also a soot-based ink, only has the two big main broad peaks. And when we started looking at other ink sticks that we had available to us, this is just an ink stick from Korea and from Taiwan that were sort of the first samples I looked at when I started this project to see if it was approachable. And you can see that these spectra are all looking remarkably similar to the eye. And it'd be quite difficult to say that there was anything to distinguish between them. So we took all of the samples that we had and we said, all right, well, let's look at 25 or so different spots on each sample that we have. We want to make sure that we're really getting a clear picture of what's going on with that sample. If the sample is homogeneous or if it's heterogeneous, and can we ascribe these differences in spectrum to differences in the sample, or is it all just a big mess? And the other thing we did is we take our Raman spectrum here. We have these two big broad peaks, but we can actually get 5 pieces of data out of that. We fit the peaks and we can figure out how wide each peak is. These are termed the G peak and the D peak. We can figure out exactly where the Raman shift of that D peak or the G peak is, and we can look at the ratio of the height or the intensity of the peaks to one another. Our Raman intensity varies based on the laser power. And I explained to you earlier that we're always trying to keep the laser power as, low enough so that we're not causing any damage, high enough so that we are still getting a Raman spectrum, and we're always balancing that out from sample to sample and work of art to work of art. So the Raman intensity itself, those numbers are going to change based on the sample and so on, but the ratio between these two peaks is not going to change. So that's how we get 5 pieces of information out of this one sort of blobby spectrum. We've now started doing some statistical analysis. This is something called correlation analysis. And what it does is it tells us whether any of these variables actually are correlated with one another, or whether they have basically, whether they're not independent of one another. And what we found is that there's very few correlations between the variables. This is good because it means that we do actually have 5 full variables from our one Raman spectrum. And it also shows uneven distribution. So these sort of bar charts or histograms here, you can see are sort of lumpy. You don't have one smooth bell curve like you might be used to seeing sometimes. And again, that's actually a good thing, because it means when we looked further down into the data, this lump over here was all coming from one soot sample. This lump over here was coming mainly from one soot sample. And so that means we are starting to see differences, even if our eye is a little too clumsy to pick it out. There are differences between these different Raman spectra. The next thing I looked at was something called peak dispersion. So I looked at Raman not only with one laser wavelength at 785 nanometers, but at 2 laser wavelengths. I added one that's close to the UV at 405 nanometers. That's in the blue. And if you look here at our D peak position, we can see that for 785, all of our soot samples, and this is similar to the bar chart, it just puts things in a little bit better perspective, but this is essentially a histogram of those samples. And all of those D peak positions are here off to one side. For the 785 and for the 405, they're separate up. And that D peak position has moved when we've changed the wavelength of the Raman laser. Whereas the G peak position, you can see, I hope, that the red peak here for the 785 is all falling in one place, whereas at the 405 nanometer, some of those soot samples, the G peak position changed. And for some of them, it's exactly the same as it was for the 785 nanometer laser. And so that's what's called peak dispersion. We have no peak, just G peak dispersion for some samples, and we have some G peak dispersion for others. The soot community and combustion community has told us that samples that have little G peak dispersion tend to be more graphite-like or graphitic. And this is just another way of looking at that same information. Here, I've averaged together all of the D band peak positions for a sample, and it's given us this line. At this edge of our graph is the location of the D band peak position at 785 nanometer excitation, and here it is at 405, and you can see for the D band position, it doesn't matter whether it's a carbon black sample or a pine soot sample, they all show very similar D band peak dispersion. But for G band peak dispersion, it looks like a pile of pickup sticks. Now I've colored these according to what type of soot we think we know that we're looking at. And what you might be able to see is that the yellow lines are mostly horizontal. They're showing very little G band peak dispersion, and those are the traditional lampblack samples that we were able to collect. The pine wood samples or pine soot samples mostly showing some positive peak dispersion in the red, and then the carbon black and the lamp blacks, where we weren't sure if it was a modern method or a traditional method, tend to be all over the place. And so this gave us hope that we might actually be able to, on a work of art, tell the difference between a traditional lamp black and a pine soot, as long as we can assume there's no carbon black present. And the last sort of method of analyzing our data that we've used is something called principal component analysis, or PCA. And we've taken those 5 peak fitting parameters, the D peak position and the D peak width and so on, for both the 785 data and the 405 laser data, and taken all those 10 variables and combined them into 3 what are called principal components. And so the principal component 1 and 2 are here. They're just mixtures of all of that data that a statistical program goes through and does its best. It's trying to spread out that data as much as possible, so you don't have things all lumped together into those bar charts anymore. We're trying to spread the data out to see if we can find any clusters. Now, these are all the different shapes and different colors in this graph refer to the different sample that the spot is coming from. And you can see they're starting to cluster. So here we have one cluster of green crosses. Here we have a cluster not quite as tight of blue diamonds, and so on. And so that tells us that we might be able to separate out different inks on a painting, because we can start to separate out clusters here just using principal component analysis of the data that we've acquired from Raman spectroscopy. But if you're looking at this and you're going like, lady, you're crazy, some of these spots are right on top of each other. I just want to look a little bit at this one more closely. Here we have these red circles and these blue stars right on top of each other. Those are two separate samples merging together. And here I just colored the data a little bit differently. So now we have it colored. We can see that those are both pine soot samples. And in fact, when I dove into the data a little bit more and looked at exactly what samples those were, it turns out that one is a pine soot sample that came from a person who only makes pine soot. That's all he does. He then sells the pine soot to people who use it for making ink sticks or other purposes. And one of them is an ink stick workshop where they do not make any of their own soots in-house. They buy in pine soot or lampblack or so on from other manufacturers. And so we're going to contact them and I think that what happens there is that we've actually found the source of the pine soot that workshop is using. So just to sum everything up, we wanted to know if we could identify the difference between pine soot or lampblack, and we think we have a way forward with that. Can we differentiate between two different inks on an artwork? We think yes, we can probably tell that they're different from one another. And what remains to be seen is really how narrowly we can identify the soot that was used, and whether or not we can do this on a work of art. And that's all stuff we'll go find going forward. And I just want to sort of emphasize that you will remember from your high school chemistry lab where you had a lab partner, no scientist is working on their own. It's always a team effort. And these are just the various people who've contributed in ways that are too numerous to name. Ink workshops that were really generous with sharing samples, the fellow staff at the Freer and Sackler galleries for just good conversation and so on, sources of funding to allow us to travel to these workshops in China and Japan. None of the study could have been done without the help of all of these people. And so now I'd like to open the floor up, if you have not all fallen asleep, for any questions.
Jennifer, thank you for a really thought-provoking talk. That was really interesting. And I appreciate that you were giving us an overview of how the soot is produced, the ink sticks are produced, but as well the technical side of it as well, because those are two sides of what you're looking at. So very, very helpful. I do appreciate that. Now we have had a number of questions, so I might as well jump right in with those. I found the photos really, really helpful to understand the process and understand how this is being produced and what it is. So we did have a question asking if you took the photos at the factories, did you actually visit them, and can you say a little bit about China, Japan, the different regions, differences that you noticed that might affect the results of the soot that's produced?
Yes, I was given a grant by the Smithsonian to go visit a number of workshops in China and Japan. Unfortunately, I have not been able to visit Korea yet to see. I know they have a traditional pine soot manufacturer there, at least, as well as I'm sure other people that I'm just not aware of today. And it is really interesting to look at. Japan has a long, continuous history of ink manufacture. And so two of the workshops that I visited there are hundreds of years old and have been making inks continuously, ink sticks for that whole time. And so they really have a lot of the tradition and so on really present always in everything that they're doing. In China, ink sticks are treasured. They're considered one of the 4 treasures of the scholars' workshop. I can't remember if I'm getting that phrase right, but it's in English anyway. So, and they're mainly in Anhui that they're made, and there's a huge concentration of people. We visited both sort of one-man workshops where it's one guy who is making soot and making it into ink sticks. And he does not carve his own molds. I believe he works with somebody who's also in his same town who carves the molds for him. But he really is sort of a one-man operation. His daughter has no interest in coming into the business. So this is sort of the one time we had a chance to see him. But there's also workshops there that are 100 people and making massive quantities of ink sticks. So those pictures that you saw where they're just lines and lines of racks drying. There are also some really big manufacturers in China as well. And so it's really interesting that you can see both of those. Some of the workshops that I visited are private. And so I was just lucky to be given access to them. But in both Japan and China, there are workshops that do have public tours that people can go through if they're interested. So it's sort of not a secret. They'll show you and demonstrate. They're very proud of this. The one thing that did happen in China is because during the Cultural Revolution, there was sort of an interruption in a lot of that ink stick manufacturing that went on. So, and I think that's part of why you'll also see in China why they invented that new method of making lampblack, was because sort of they have that interesting mixture of, they have the long history of it and the long, we saw that thing from the Ming dynasty manual, and I'm going on at length, I realize. But they also have this sort of new mindset of coming into things after that Cultural Revolution was over and they started to bring ink stick manufacturing back. So it just makes it really interesting.
That is a great overview. Thank you so much. And for me, the takeaway is to know that there is obviously a demand and an interest in traditional ink sticks. So they're clearly being used today, which is very exciting and hopeful. Now I'm going to step over to the technical side of things a little bit. Several of the questions relate to the actual ink sticks themselves. So people are asking, how can you be sure that the chemical structure of the carbon pigments have not changed significantly with time? And I'm going to tie that in with, I know that ink sticks are obviously a combination of glue and soot and maybe some other factors. So how do those affect the carbon and therefore your research into it?
There's sort of two separate things going on. One is we just are really lucky that the Raman, the biggest thing in the Raman spectra of an ink happens to be the soot. We could have definitely fallen the other way and found that the biggest thing that was the animal skin glue. And then this project would have had a whole different turn. But because there's only two peaks present in that Raman spectra, and we know from the extensive amount of work that has been done looking at Raman spectra by the combustion industry, which is a gigantic industry. No one who isn't in it has any idea how big it is. But that those are from the soot. And now it is quite possible that changes have occurred over time. That's something that we'll have to be looking at right now. And I didn't say this, I think, in the lecture, but right now, all of our work has been done on the samples, the soot and the ink stick samples that we've collected. We haven't started looking really at paintings yet. So, in another year or so, you might be coming to a completely different sneak peek talk where we're talking about how we've had to change all of our ideas once we're working in those older things from paintings. I have been lucky enough to look at the Department of Conservation and Scientific Research has a historic pigment collection, and we have some 100-year-old fragments from 100-year-old ink sticks. Many ink sticks will have the date impressed upon them in the mold, and so sometimes you're really lucky and they can actually be dated very specifically. And I can tell you that they have very similar characteristics to what we've been looking at so far. But that's still, we're only talking about 1 century, not the multiple centuries that encompasses all of the works of art in our collections. So that's something that sort of remains to be seen. You definitely have things that degrade all the time. Soot is, in general, a fairly robust molecule. And is not prone to a lot of deterioration. It's made from carbon to carbon bonds that are very stable, similar to graphite. And if you think, graphite is actually mined from the earth, so it's sort of sat there in the earth for years and years, just being itself. And we expect to see some of the same lack of deterioration in soots.
Thank you. That is a very useful solution. I appreciate that. Now we're running out of time here, so I'm going to ask you one more quick question. People are interested in how you know, in that one example you showed, that the painting and the inscription were from different periods. And can you say a little bit more about what you're finding out about the different kinds of inks and how that might affect how you're looking at paintings and beginning to differentiate the different times that inks were applied or the different types of inks that were applied?
I know that because I work with a great group of colleagues. It really does, it all ties together. We know that because of the curatorial work that's been done by the different Chinese paintings curators over the years. That particular inscription was signed by the emperor who wrote it, and we know the name dates, or we know the life dates of him. He may have even dated the inscription. I can't remember right now. And we know when the painting was painted, and they are centuries apart. But yes, that's not me. That's all the research of the curators. And so any museum research project is always a collaboration between the scientists like me and conservators like Andrew, and curators who you've heard from in the various sneak peek talks elsewhere.
Great. Yes, it's always a team effort. So thank you for your talk. It's really been very interesting, and there are a lot more questions that we haven't been able to answer, but I just want to say thank you for joining us today, and that you can find more information on this and other events on our website, asia.si.edu/events. For additional questions, or those that were not answered today, you can direct those questions to our Scholarly Programs and Publication Department by emailing asiascholarlyprograms@si.edu. Thank you so much for joining us today. Do stay safe.